Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations. So let's get going. Problem. Solve d cube minus 4d square plus 4d into y equals to cos 2x. So firstly, let's find order and degree of the given equation. Identify the highest derivative. Here, d cube is the highest derivative, so our order will be 3. And the highest power of the highest derivative is the degree. Or you can just write the given equation as d cube y minus 4 d square y plus 4 dy equals to cos 2x, right? We know that differential operator d equals to d by dx and d square is d square by dx square and d cube is d cube by dx cube. Then we can write the given equation as d cube y by dx cube minus 4 into d square y by dx square plus 4 into dy by dx equals to cos 2x. So here our highest derivative is d cube y by dx cube. So our order will be 3 and the highest power of the highest derivative is our degree. So degree will be 1. Now coming to the problem. We are given a differential equation which is in operator form and also it is in f of d into y equals to q form, where q is in cos ax form, right? Solution. Given differential equation. D cube minus 4d square plus 4d into y equals to cos 2x, which is in operator form. F of d into y equals to q, where f of d equals to d cube minus 4d square plus 4d and q equals to cos 2x. So here we have to find the general solution to the given non-homogeneous equation using y equals to yc plus yp. Here yc represents complementary function and yp is a particular integral, right? We'll find yc using roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by equating RHS to 0, we'll get the homogeneous equation. We'll take RHS to 0, then we'll get some f of t into y equals to equals to 0, which is a homogeneous equation of the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. So firstly, let's find complementary function using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d equals to d cube minus 4d square plus 4d, right? So let's replace d by m, then we'll get f of m equals to m cube minus 4m square plus 4m. Fine. Now, our auxiliary equation becomes m cube minus 4m square plus 4m equals to 0. Now let's take m common from all these three terms. We'll get m times m square minus 4m plus 4 equals to 0. Right? Then equate each term to 0. Take m equate m to 0 and equate terms under brackets to 0. Okay. Here we are having m square minus 4m plus 4 equals to 0. We can just factorize it, or we can write minus 4m as minus 2 into m into 2 plus 4 as 2 square equals to 0, which is in a square minus 2ab plus b square, expansion of a minus b whole square form. Right? From this we'll get m minus 2 into m minus 2 equals to 0. Now we can write this polynomial. I'm not talking about the equation, I'm just talking about the polynomial. We can write this polynomial, that is m into m square minus 4m plus 4 as product of m into the factors obtained from this polynomial is m minus 2 into m minus 2. Right? Then we can write this equation as m into product of m into, or product of m minus 2 equals to 0. Okay. So by equating each factor to 0, we'll get m equals to 0, m equals to 2, m equals to 2. Then the roots will be m equals to 0, 2, 2. Right? Here 2 is repeating twice, so we call these two as equal roots and one distinct root. We have one distinct root and two equal roots. Therefore, m equals to 0, 2, 2 are the roots of our auxiliary equation, which are, we have one distinct root, right? Distinct and equal. We have, better, we can write one more sentence, that is, we have one distinct root and two equal roots. Right? We know that if two roots are equal, or if we have one equal root, then the solution for this will be constant into distinct root, e power distinct root into x, and for equal roots, the solution will be constant. See, we are having two equal roots, so we'll get two terms under bracket c2 plus another constant into x into e power equal root into x. Right? Or in general, you can just write m1 root. If you consider the distinct root as m1, then the solution to this will be c1 e power m1x, and for the two repeated roots, we'll get that. If you consider the other two roots as m2 and m3, then m2 equals to m3, and for that you will get solution c2 plus c3x into e power equal root into x. So therefore, complementary function will be y is equals to, firstly let's write for 0, c1 e power 0 into x, plus next we'll write for 2 equal roots, c2 plus c3x into e power 2 into x, which is equals to c1 e power 0 into x is 0 plus c2 plus c3x into e power 2x, right? Therefore, y is equals to c1 plus c2 plus c3x into e power 2x. Now let's find yp. We'll find yp in two ways. I'll show you in two ways, okay? Particular integral. We can find particular integral using 1 by f of d into q is equals to 1 by f of d. We have d cube minus 4d square plus 4d into q. Here q is in cos ax form. Okay. So here d square is given by minus a square, which is a formula. Which is equals to minus, we have a equals to 2, then you'll get minus 2 square equals to minus 4. Now let's find what we'll get by replacing the denominator, that is d square in the denominator. We are having d cube minus 4d square plus 4d, right? We can write d cube as d square into d minus the remaining terms will be same. Then, now what we have to do, we have to replace d square by minus 4, then we'll get minus 4 into d minus 4 into d square can be replaced by minus 4 plus 4d, which is equals to minus 4d. Minus into minus plus, 4 4s are 16 plus 4d. Here plus 4d minus 4d gets cancelled, then we'll get 16, right? Which is not equals to 0. So from this we got to know that by replacing d square by minus 4, the denominator will be not equals to 0. So we can dare to replace. Okay. Firstly, we'll write d cube in terms of d square. Now we can replace d square by minus 2 square, which is equals to minus 4, right? Then we'll get 1 by minus 4 into d minus 4 into, replace d square by minus 4. We are just writing the same terms here. 4d into cos 2x. This becomes 1 by minus 4 into d minus 4d. Minus into minus plus, 4 4s are 16 plus 4d into cos 2x. Which is equals to, here plus 4d minus 4d gets cancelled and you get 1 by 16 into cos 2x. Therefore, yp equals to 1 by 16 into cos 2x. Right? Now, we can see another way. We know that yp is given by 1 by f of d into q, right? We have f of d d cube minus 4d square plus 4d, and q is in cos ax form, right? Now, let's take d common from all these three terms, then we'll get d square minus 4d plus 4 into d into cos 2x. Now we can split this fraction as 1 by d square minus 4d plus 4 into 1 by d, right? So firstly, we can find 1 by d into cos 2x. Integral cos 2x dx, which is equals to 1 by d square minus 4d plus 4 into, we know that integral cos ax dx equals to sin ax by a. Then for a equals to 2, we'll get sin 2x by 2, right? So which is equals to, we can write again this as 1 by 2 into 1 by d square minus 4d plus 4 into sin 2x, which is equals to 1 by 2 into. Now let's see what happens if we replace d square by minus 4. Okay, I'm just writing the same thing. We'll see what happens if we replace d square. D square equals to minus a square, which is equals to, for a equals to 2, you'll get minus 2 square, which is minus 4, right? Now we'll check the denominator by replacing d square by minus 4. Here plus 4 minus 4 gets cancelled and get minus 40, which is not equals to 0. Since by replacing d square by minus 4, we get the denominator something which is not equals to 0. So we can replace d square by minus 4, right? Then this becomes minus 4d. I'm writing the same steps. Sin 2x is equals to 1 by 2 into 1 by minus 4d sin 2x, right? Again, you can split 1 by minus 4d as (1 by minus 4 into d into sin 2x). Now let's split the fraction as 1 by minus 4 into 1 by d into sin 2x. We can write 1 by minus 4 as minus 1 by 4 into 1 by d sin 2x. Okay. So minus 1 into 1 is minus 1 by 2 4s are 8 into 1 by d sin 2x is integral sin 2x dx. Since we know that integral sin 2x is minus cos 2x by 2, or we know that integral sin ax dx equals to minus 1 by a cos ax or minus cos ax by a, better, right? Then yp becomes minus 1 by 8 into integral sin 2x dx. So for a equals to 2, we'll get minus cos 2x by 2, which is equals to minus into minus plus cos 2x by 8 2s are 16, or 1 by 16 into cos 2x. So you'll get the same answer. You got the same answer, right? For yp. Therefore, yp equals to 1 by 16 into cos 2x. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to, we have yc c1 plus c2 plus c3x into e power 2x plus yp 1 by 16 cos 2x, which is the required solution. Therefore y equals to c1 plus c2 plus c3x d power 2x plus 1 by 16 cos 2x. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you on the next video. Bye bye.